Hello, our most valued student. My name is Confident. Welcome to our revision of the Mathematics N3 question paper that was supposed to be written in April 2020. And I'm looking at question 2. We have already looked at question 1. If you missed that lesson, I will encourage you to go through that lesson as it has got some important tips on how you could have done your first question. Now let us continue to look at question 2. This is question 2.1. It says simplify the following, and this question had 3 marks in total, and you are supposed to simplify. It's got a little bit to do with exponents. At the same time, it's got to do with expansion. If I can write that, actually let me try to expand that so that it is much clearer. So you're requested to simplify, that is 3 marks. So a few things here that you were supposed to be in check for. You see, you have got a division here. This is a division sign, as well as you have a negative sign. So this only a division sign and a negative. It means if you try to simplify this part, which is 1 over x plus y to the power negative 1, just this part will become 1 over. Now to get rid of this particular negative using the laws of exponents, if you still remember, there is a law of exponent which says a to the power negative m is equal to 1 over a to the power m. So to get rid of this negative m, you have to put a 1 over. This is how you get rid of it. So this negative m, you put a 1 over to get rid of that negative. So in the same way, if I want to get rid of this particular negative sign here, I must again put another 1 over, and then I can write it now as x plus y. I can leave it like that, or if I'm to put that, it will be now to the power positive 1, which is same as x plus y in this case. So I can just leave it like that. Now when I've got 1 over x plus y, let me just show you with a calculator an example. If I have, just remember one thing, the fraction here is this part. This is my fraction. I'll show you why I'm doing that. Now let's take my calculator. So with the calculator, I can choose any number. For example, I can say 1 over, and then there is a fraction. I press that fraction button. I say 1 over 5. So you see where the 5 is? Now you see I'm getting a 5. But don't do it like this. Don't say fraction. If you do it like that, then you'll have 1 over 5, 1 over, in this case you can see now you're getting a 1 over 5. So be careful. How do you punch it? You say fraction, don't put another fraction where the cursor you can see is on top. You play down so that at the bottom, that is where your fraction is according to this. That's why you have got your 1 over, for example, I'll say a 9 there, and then on top I've got I wanted to play backwards. I've got my 1 there, so you can see it gives me a 9. So which means this particular example, 1 over x plus y, it will simply give me the bottom one here, which is in this case the x plus y. So that is what I wanted you to realize there, so that they don't trick you in any way. The next part now that you are given, which also was important for you to solve, it was this part of, if I can have here another pen, it is this part of x to the power half minus y to the power half. If they use the square there, you can see they use a square there, The square there, what it simply means, it means this is happening twice, so it's x to the power half minus y to the power of half. That is basically what that particular square means. And when you have done that, it means you must expand, whereby this will multiply the first one and that will multiply the second one. You do the same thing with y. It means y will multiply that and y will multiply that. So it's mainly a matter of expanding, but as I said, this they were checking if you know your exponents when you're expanding. So remember that. So if I can now solve this and say from my original here, if I can now simplify it, it will be equal to, remember we've already simplified that. The first one is x plus y, if you still remember that one, and then it's minus, so let's keep that in check, and then we've got your bracket. We're saying it is if I'm now to expand from what I've been writing, this is if I'm using now this x times x, you can see that it is x to the power 1 over 2 times x to the power 1 over 2. The next one is x to the power half times y, which is a negative though, which is minus x to the power half times y to the power half. If you repeat the step, now it's y and x, it will be minus, but you can always start with the alphabetical x because it begins before y. So it's x to the power half times y to the power half. It is also fine to say yx, but you can always start with x and y so that it easily matches there. Now minus y to the power half times minus y to the power half, and negative and a negative will give you a positive y to the power half times y to the power half. Now when you've done that, close the bracket, which is equal to x plus y minus, now if you remember your laws of exponents, in this case, that's what, as I said, they were checking. Remember, a to the power m times a to the power of n. Now if the base are the same, what you did was a to the power m plus n. You were adding your exponents. So in the same case, even here, when we are given x to the power half times x to the power of half, you can see the bases are the same. So you say x, and then you've got 1 over 2 plus 1 over 2. So what is 1 over 2 plus 1 over 2? It's x to the power of 1. That's what they wanted to check. But if you are given x to the power half times y to the power half, you see the bases are different. This, you leave it like that. So basically, this is what you are supposed to be doing. So if I can now use that concept, I will say now x to the power half is similar to x to the power 1 minus, this one can remain as it is, but there are two of them there. It is minus 2 x to the power of half y to the power of half, and then after that is plus, again the base is the same for y, so it will be y to the power of 1, just like we did for x. This is equal to now x plus y. Now I need to open up this negative, so the negative will affect each and every term, and it will be changing the signs there. If x was positive, now it's negative x. From the negative, it will be positive 2 x to the power half y to the power of half. Now it's minus y in this case, and then bring all the like terms together. It is x minus x in this case plus y minus y plus 2x half y half. You can see now how this whole thing, where the examiner was taking you, so that this was supposed to cancel, this was also supposed to cancel, and then your final answer was supposed to be 2. Is not what's supposed to be. Your final answer is that, if you're working on that. All right, so now let's say this is your final answer. Actually, you can even move on to say this is the same as saying 2xy, put a bracket, and you can see that the power of half is the same for x and y, so you can put a bracket for that to say the power of half is affecting x and y. Now, if this is the case, you can also do, remember that proof that I did, I can also put, I always prefer this proving because it makes me feel more confident about my simplification. Let us look at this proof. Let's say I want to prove and see if my answer is correct. It's not an equation as such, but an expression also you can try to prove. Let's say I want to prove and say, let my x be equal to 2 and let my y be equal to 3. So where there is an x, I put a 2. Where there is a y, I put a 3. I can start with my final answer here, so that I will have 2xy to the power of half is equal to 2. Remember, my x is 2, my y is 3 to the power of 1 over 2. So what is my answer there? Of course, I need the calculator. It will be 2 bracket 2 times 3 to the power of a half. I'm getting 4.898. Actually, it's 4.899, but let's just say 4.89 in this case. So it's 4.89. Now remember, I said this is the same in this case. You can have used that 2 times x. We said 2 to the power of half. The one I said is similar, times y is 3 to the power of 1 over 2. So you can see that I'm still getting 4.89. So far so good. Now let me go to the original now. My original is this one. Now with this original, I'm going to input the value again. Where there is x, I put the value of x, and where there is y, I put the value of y, and see if I'm going to get the answer that I got previously. So I've got fraction 1 over bracket, it's x, we say it is 2 plus y is 3 to the power -1, remember, and then play forward, put a bracket, and then you've got your x, and remember your x, we say it is 2 to the power 1 over 2, and then you've got minus, and then the y is 3 to the power of 1 over 2, and then this everything is to the power of 2. So when you've done that, you put an equal sign. I'm getting that. Think I made an error there. Okay, I see where the error is. Just look at the error there. It's different, but there is no sign there. I must put my negative sign. Okay, let's try see again if I put everything correctly. It's 1 over 2 plus 3 to the power -1 minus 2. X is a 2 to the power of half, remember. Y is a 3 to the power of half, and the squared, I think is fine. Now look what I'm getting. I'm getting the same answer, 4.89. Yes, it is the same. So it means my simplification that I did in this case here, I have got more confident that this answer is correct because it is matching. It means the simplifying from the beginning to the end, nothing has changed because it is still maintaining the same answer. Now let us move on to question number 2. Now question number 2.2.1, it had a 2.2.1 in this case, so which means there is a 2.2.2. Let us start with the first part of it, of 2.2. It says solve for x. So there we are now solving for x without using a calculator, showing the following. So with solving for x, you can actually easily prove your answer in that case. Now we are solving for x and we're given logs, and this was 5 marks in total. And let me expand that. Frankly speaking, this question is common in the exams. They usually like this kind of question. I've seen quite a number of papers having some questions like this, whereby you are given a log base x and log base a and another log with a different base, and you're supposed to solve. So for me to be able to do that, the formula sheet can assist me in this case. For example, I want to change this. This is how you solve this question. You have to change one of the bases. For example, I want to change this into base 3. And there is a formula for that. If I can, let me check. Yes, there is a formula sheet. So there is a formula. If you go to your logarithms and under logs, this is the formula sheet for logarithms. And if you look at the formula, there is one for changing bases. It is this particular one. It is this one that I'm preferring. Even this one kind of changes the bases. You can see this was base B, now it's base A, but I'm interested in this one whereby you are having a base B. Now the base in this case has changed from C. So if we can write this formula, log base B of A is log base C of A over that. If I can write it as it is, I will have the formula says log, in this case it said what, base B of A is equal to log base C, in this case of A, over log base C of B. Now look at this particular formula. I'm going to use it to change. Now let me change it. I want to change log base A of x into base 3. Why am I using base 3? Because I have a base 3 there. So I want to match the bases. So I will have in this case log base 3. So where you can see the A is the one that we start with. So here I'll start with x over log base 3. As you can see now, it will be A. So this is how I've managed to transform that. So if I can rewrite my question, remember I had log base A of x times log base 3 of A. This was equal to 4. So now I have managed to change that log base A of x to give me log base 3 of x over log base 3 of A. Remember that? Times, now I'm multiplying log base 3 of A is equal to 4. And you can see something interesting there now, such that this one and this one cancels. That is the main reason why I was changing everything into this particular base, so that now I have log base 3 of x is equal to 4. Now these are log equations. Let me check on the formula if we have log equations. Unfortunately we don't, but you need to know when you're using with the log equations, what you do is when this particular base is you must change it into exponents. It means x, in this case this x is equal to that base become 3, and that 4 becomes an exponent, which is 3 to the power 4. So x is equal to, now if you simplify 3 exponent 4, you will get 81. So our value of x here is equal to 81. All right, now when you have done that, you can actually prove your answer in this case. With this, it's not difficult to prove because you have got your value of x. So proof. Now we know our x is equal to 81, but because we still need our base a, let a be equal to, let's choose base 10 for argument's sake. So now if I do that, I will come here in the original. Remember, this is the original one. You say is a log, I must punch that log. I said let's use base 10. Now my x is 81, remember, times log in base 3 of a remember is, I said is 10. If you say equal to, you see I'm getting 4 as my answer. Now another person could have approached it differently. He could actually have said, I do not want, okay, let me not erase this, but let me write it in another part. Someone would have said, if I can write this again here and say, remember I was given log base a of x times log base 3 of a is equal to 4. Someone would have said, I'm interested in changing this particular part so that it matches, so which means you must change base 3 to base a. So you will also use and therefore and say log base 3 of a is equal to, then you say you want to change it to base a, you're going to say log base a of a over log base a of 3. Now go to your formula sheet. Remember log base a of a is 1, so that you will have 1 over log base a of 3. Actually, this particular formula leading to that answer, it is this particular formula, the second one here, that they're showing to say log base b of a. If you want to change it to log a, then it's 1 over log a of b, if you say that. So it's log 3 of a, and you want to change it to a of 3. So you are going to have that. Then you are going to be able now to say, if I've got this, I can now, where there is a log base 3, you can now say this is log base a of x times, remember this is 1 over, in this case now, 1 over log a of 3 is equal to a 4. So now when you have done that, this is the same to say, if you continue, log base a of x over log base a of 3 is equal to a 4. So now when you have done that, you can see that you have a log base a, you have a log base a of x, and you've got a log base a of 3. This is the same. Let's check if there is a formula for that. Now it is, we are using this particular formula. Now we are here, now moving in this direction now, such that what we are having is, you are having, if I can actually take it, I'm having it here. You can see this particular formula here. In this case, I'm having log base a of x and log base a of 3. If I'm going backwards in this formula here, you can see that even at the bottom here, the one that I'm having in this case, I'm going to have, this will become log. Now where, remember I was having my C and my C, and then I've got my A and my B. The bottom B is the base. In this case, 3 is the base here. This B is the base, and this A is the number. So even here, this 3 will be the base, and this X will become the number, which will be in this case X, then equal to 4. I hope you're able to see how I transformed that. And then it simplifies further. Say X is equal to 3 to the power of 4, and we did find that that was equal to 81. So this is another way someone could have approached it, but at the end of the day, it was going to give you the same answer. I hope it's up to you which one you choose. All of them, they simplify to give you the same answer. Let us look at the last part of it. Question 2.2.2. The whole of question 2 was 14 marks, and this one in particular was 6 marks. Says solve for X without using a calculator, showing your working. It wasn't a difficult problem. Again, you will meet this kind of problems. It is another version of the K method. So with the K method here, what you were given is difficult for you to solve this as it is. You have to use the K method. So when I'm using the K method, so what I'm going to do is I'm going to let this be K, and where there is that, I put a K. So what is my K in this case? Let K be equal to square root of 3x minus 1. So I will have this particular question therefore simplifying as 6 over K minus 1 is equal to K. So you see how it's happening. And then for me to simplify now, that I will have to multiply this by K, each and every item multiplied by K, each and every item multiplied by K. It's much simpler like that. And then you will have here 6 minus K is equal to K squared. Then you have to take everything to the one side, which is 0 is equal to K squared plus K minus 6. It is a quadratic equation. Therefore, I've got K squared plus K minus 6 is equal to 0. You need to factorize this part using product sum method or whatever way. So I have my K plus 3, and then I have my K minus 2. You can solve it whatever way, but I'm using the product sum method. So you can see now my first value of K plus 3 here is equal to 0. Therefore my K is equal to minus 3. That's the first part. Or K minus 2 is equal to 0. My K is equal to positive 2. So I've got two values of K, but remember, this is not my answer. I said let K, remember the assumption, K is equal to square root of 3x minus 1. So I need now to solve in this case for my x, because I'm looking for x, not for K. So which means square root of 3x minus 1 is equal to minus 3. This is where K is equal to minus 3. This is the first answer that we got, where K is minus 3. Now how do I solve that? If I do that, square both sides, and then minus 3, I square both sides. That's how I get rid of that square root. So I'll have 3x minus 1 minus 3 squared will give me a positive 9. Now let 1 jump the equal sign. It will be 3x is equal to 9 plus 1, which is a 10, divide by 3. So you can see that is my value of x there, such that x is equal to 10 over 3. My value, first part. What about when k is equal to 2? Therefore, I will have again square root of 3x minus 1 is equal to 2. As I said, square both sides and square both sides. That's how you get rid of that square root. 2 squared is a 4. Let 1 jump the equal sign so that 3x is equal to, it becomes a positive, which is 4 plus 1, which is a 5. Divide by 3, and then you will have x is equal to, in this case, 5 over 3. So now you have got two values of x. So far so good. But whenever you are dealing with this kind of a problem, I will always tell you, you need to test your answers. You definitely need to test your answer. So now, how do you test your answer in this case? You need to come and say test. The first value is x is equal to 10 over 3. This is very important because sometimes we find that one of the values is not does not meet the condition. So whenever there is x, so what you're going to do is, like you're saying here, 6 over square root of 3 10 over 3 minus 1 is equal to square root of 3 10 over 3 minus 1. So you see what I'm doing? This is how we're going to be testing the whole thing. So if I can take my calculator, remember the left hand side must balance with the right hand side. So let's start with the left hand side. I've got 6 over square root of 3 into fraction 10 over 3, and then I've got minus 1, and then I have minus 1 outside like that. I'm getting a 1 on the other side. You can see that on the other side is a 1, so I can write it as a 1 there, is equal to, let me check the other side what it gives me. I've got square root of 3 into 10 over 3 close bracket minus 1. I'm getting, you see now, I'm getting a 3 on the other side. So you can see that there is no way that 1 can be equal to 3. This is not. So it means this part is not the solution. So this one is not the solution. I'll show you how you write your answer at the end. Let's look at the second one. The second one now, we are also going to test it. I'm given, if I'm going to use my white marker here. If I can just move this a little bit this side, all right, just so that I can have a little bit of space. So if I can have again, so what I have got on the left hand side, it was 6 over square root of 3 into 5 over 3 minus 1. Minus 1 is equal to square root of 3 into 5 over 3 minus 1. So let us test this one. So I've got 6 over square root of 3 into 5 over 3 All right, -1, play forward, and -1. I'm getting a 2 this side, so 2 is equal to, I do the same thing on the other side. I've got a square root of 3 into fraction 5/3, and then I've got -1 in this case. I'm getting again a 2, so you can see that 2 is equal to 2. So therefore, how do you write now your final answer? You are going to say answer. Okay, use a different marker there. You are going to write your answer and say x is equal to 5/3, and then you are going to say but x is not equal to 10/3. So this then becomes your answer. The fact that you are telling the invigilators that not the invigilators, sorry about that, the fact that you are telling the marker, because this is now the marker who's going to be marking your paper, the fact that you're telling the marker that you are aware that one of the solutions is not a solution is what they are looking for, then they will give you all your marks. And we say this was equal to 6 marks. But if you left your answer without telling us that x, one of them, is not a solution, you're going to get 5 marks out of 6. Now we have come to the end of our revision session where we looked at question 2. Join me again when I look at question number 3. Thank you.